Welcome back my dear friends, participants and students for this multi-criteria decision making course which is under NPTEL MOOC series, and as you know this is spread over 12 weeks with 60 lectures, and each week we have 5 lectures, each lecture being for half an hour. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you remember for the last few classes, about 2 weeks we are discussing about the multi-criteria decision making, where the decisions alternatives criterias are more subjective, not objective as like in MODM, and we were discussing concepts of Topsis method, and we are in the process of discussing the ELECTRE method. And in the ELECTRE method, obviously you will see in the slides we are discussing about the different type of distance measures like the Manhattan distance, the L infinity, then L2, which is the general distance measure between 2 points in the coordinate system. We did mention about Mahalanobis distance, Hamming distance, but all our focus would be in different LP norm or the LP distances, considering the Manhattan at one end and the L infinity distance at the other end. And this is the 45th lecture, which is the last lecture in the 9th week. Broader umbrella, as I keep repeating, is basically MCDM. We have already covered MODM, few of the techniques. We are into multi attribute decision making and the different techniques, like as I mentioned few minutes back, Topsis, ELECTRE, HP, YCOR and all these things. So, the coverage is where we started and left in the last class was ELECTRE method, which is elimination and choice translation reality. Now, if you remember, we had drawn and considered the two different points x and y. If you follow the last lecture, you will understand x and y, and they are in 3 dimension, like x is a vector which has x1, x2, x3, y is a vector which has y1, y2, y3 are the coordinates, and based on that we found out what was the distance based on Manhattan norm, then L2, L3 till L infinity, and we plotted that, if you remember that. And I showed you that for Manhattan norm it was the max, and L infinity it was the minimum. Now, further analysis of that, I have drawn this graph where the same ideas has been converted into the concept of different coloring. And if you notice, there is a red color, blue color, green color and yellow color. Now, if I consider first the green one, so let us consider 2 different points. I will mark them as A here, B here, and if I have the coordinates, this is a 2 dimension one. So, it is easy for us to visualize. So, if the coordinate system for A are x1, y1, for B are x2, y2, obviously, I can find out the distance between A and B, which is based on square root of x2 minus x1 whole square plus y2 minus y1 whole square, and we take the square root. So, that would be given by the green line, which I will put up mark in the this one. I will just again redraw it. So, this is the, I will hash it. So, there is no confusion. This is the L2. Now, if you see the red, blue and yellow, they are as follows. The green line which I just hashed is the unique shortest path, while the red, blue and yellow are based on the L1 norm and are of the same length, but you can take different paths. Why of the same length? So, if you consider the total distance covered, same length means the L1 distance is the same length. So, if I consider the yellow one, so it goes, I am not comparing with the L2, I am only comparing the L1. So, if I take the yellow one, so I go 1, 2, 3, 4, 5 units right, then go 1 vertically up, which is 5 plus 1, then I go right plus 1 and then again go up 1 2. So, it will be going 1 2 3 4. If I see the red one, so red one basically I would go 1 2 3 4 5 6 and on to the right I go 1 2 3 4 5 6. So, let me count if I have taken it correctly 1 2 3 4 5 6 1 2 3 4 5 6. So, 6 plus 6 and in the yellow one let me count if I missed something 1 2 3 4 5 plus it goes 2 up, sorry my mistake, it goes 2 up, then goes right 1, then goes up vertical again 1 2 3 4. So, the total amount of movement, if I follow the L1 basic concept, if I follow the yellow path, it is 5 plus 2 7, 7 plus 1 8, 8 plus 4 is 12. So, yellow is difficult for you to see, but it is 12 number of units, and if I consider the red one also it is 12 units movement. So, the L1 norm different, it can have different paths, but the distance covered is same. So, that is why the L2 norm has unique solution, while L1 norm does not have any unique solution. Lengths are same, but it can take different paths. One can generalize this in the n dimension one, we did it in a 2 dimension, we can have in a 3 dimension, like corner points or some points in a cube, and I can find out the distance based on L2 and the L1. Now, why did we discuss the distance? It will be clear later on. Now, the idea is, if you remember that we were discussing the steps of the ELECTRE method, and in the concepts of what we did in the Topsis method. So, these Excel sheets which is named as MCDM, and there are different sheets inside the Excel sheet. The first one I have already sent, for the 8th and the 9th class I will send along with the slides, the Excel sheets would also be shared with the participants and the students. Now, why did I go back to the Excel sheet? If you remember, we were discussing about the distance based on PIS and NIS, and I categorically mentioned there the PIS and the NIS distance were based on L2. So, the idea was that was can we convert that into any other distance concept? Yes, it can. We will see that in the ELECTRE method. So, ELECTRE method sheet is still empty, I will fill it up with the discussions as we proceed. Now, same step set of steps. So, the steps which we had followed in the Topsis method was, first have the X matrix. X matrix is based on the number of alternatives and alternative criteria. The alternatives were marked along the rows or the criteria along the columns. Then they were normalized. Normalization is based on the different type of utility functions or normalization concept we used. And I did show in the Excel sheet, and it is also there in the video which I was delivering, that normalization was based on simple normalization like Xij. If I consider each value in the matrix X, capital X, which is matrix as Xij divided by the sum of all the Xij's depending on whether you are trying to normalize along the rows or the columns, or you can take the logarithmic value, or you can take the square values. So, in the square values it will be square of Xij divided by the sum of the squares along the rows of the columns. In the logarithmic scale, or when you are normalizing, it will be log of Xij divided by sum of logs of Xij along the rows of the columns. We will follow the same concept here also. So, here we convert the entries in the decision matrix and normalize them. Now, in the slides and in the Excel sheet or in the discussion, generally the concept of trying to convert X into the normalized vector, multiply its the weights are based on the criteria only, then proceed accordingly. The concepts and the methodology remain the same, maybe the nomenclature of what you want to mention as X or R normalized vector, that symbol would be different, but there should not be any confusion. So, you convert the entries in the decision matrix x or a into a scale normalized value. So, this would be square. So, I have aij's, xij's would be aij square divided by the sum. So, this should not be a square root, it should be just be the sum of akj square. And when I mention about the squares, so based on that I find out the normalized values along the rows of the columns. Now, what are these? These are on a scale factor of 1 or 100. If I multiply the scale factor by 100, it becomes on a 100 scale. I am trying to find out the level of importance, because the utility function based on which the person is analyzing the points or the values for each and every criteria for each and every alternatives need to be scaled and found at the same level, such that comparison becomes easier. So, once we get the normalized vector, we should remember again the point which I am mentioning, repeating, please bear with me. Here m would be the number of alternatives, n will be the number of criteria. So, here if I read the second last bullet point, here m is the number of alternatives shown along the rows and n is the number of criteria shown along the columns. The normalization which you do implicitly depends on the utility functions or the worth which the decision maker thinks what is the value which accrues to each and every alternatives based on the criteria what he or she is analyzing. So, say for example, the car example. So, the car there are m number of alternatives in front of you. The criteria can be, I am just repeating, can be the mileage, can be the cost, can be the maintenance cost, can be the safety features, can be the color, can be the luggage space, can be the number of passengers who can be carried, it can be the resale value. So, based on that the points are given. If I consider the example of college, choosing a college, it can be what is the tuition fees, how far it is from home, it can be what is the quality of the education, what are the job facilities, internship, what are the final job facilities, how are the teachers, what is the environment, and all these things can be considered. Similarly, we can consider different ideas when somebody is buying an apartment. I keep my discussion limited to these three, because they can be easily communicated with the participants and the students. Now, here let us consider, so the normalization has to change because it should be not the square root, a square here. So, let me do the problem accordingly. So, I will consider of m as 3, n as 3. So, let me mark it as A1, A2, A3, this is C1, C2, I should zoom it more, so it is visible to all, and C3, and this is, say for example, the matrix X, and I would have also have the matrix of weights. So, they would be correspond, I will fill it up just C3, and there were also C1, C2, C3, and the values are given based on 2, 1, 2, then I have 3, 3, 4, 1. I am taking the same values 1, 3, 2. Now, I write the normalized vector as, say for example, R. So, here also I have A1, A2, A3. So, the corresponding criteria come. So, now I normalize. So, let me use first. So, if I go back, the normalizations are based on the columns. So, if I consider first example, I am normalizing based on just Xij divided by the sum. So, it will be sum of along the columns. So, I need to fix the sum value, because sum value along the column does not change. So, I find it out and it is the sum I want to verify. So, it is equal to 1. So, I highlight it with the color. So, it is easy for us to follow. So, now I take as D till D. So, D columns again normalized, sum is equal to 1. I go to the third one, it means C3. So, it will be sum of E. So, I sum them up and the value comes out to 1, perfect. So, this is, I should mark this with some orange color here. So, there it's because visually much more noticeable, and this sum is yellow, and this was the weights. So, I should shift it to one box, so it is easier. So, these are the weights. I also mark it with light orange. So, we need to find out the weights. So, based on this I find out the weights. So, same concept, once the weights are found out, I need to multiply the normalized vector along the weights. Weights, remember, are based on the criteria only. What is the level of importance of the criteria, which are in some way the constraints, because alternatives are the objectives which you want to choose. Car you want to choose, buy the house, check with the college, which college you want to get admission. And once the weights are given, based on the decision maker, we will multiply the normalized matrix with the weights matrix. Only thing to be remembered, which I did mention twice, be aware that what is the dimension of W, what is the dimension of X. So, based on that you multiply. So, step 2 would be weighting the normalized decision matrix, which we will do. So, consider the weights are 1/4, 2/4, 1/4. So, is 1/4, 2/4, 2/4 is 50% and 1/4. So, double check the values of 0.25 plus 0.5 plus 0.25 should be 1. So, the other values are all 0. So, I have done this. So, let me add few rows. So, the So, what I did was, I will insert. So, I found out from x to r. So, I will put arrow here. This is the calculation which we are doing. So, I will put the arrows in black color. So, this is the calculation. Then I need to multiply the weights and the normalized vector r. So, I will put the arrows accordingly. So, but first let me put the matrix here. So, it will be MMULT of the first array into the second array. I have all the values. So, these are the corresponding values. So, once I do that, so these I will basically mention it as y, and I will mark them with red values and bold them. So, based on that we will do the calculations. So, what we do is multiply the weight with the normalized vector, this we do, and we get y vector. So, I put the arrows accordingly. In the same way, if you remember, in the topsies also I put the arrows. So, that was to avoid confusion. So, once you have y, so I would not put any color here. So, this is y, and these are the cell values for the weights. Weights I will put as blue in the same way as I did for the topsis. So, remember the weights is 1 if you think or perceive that for criteria 2 you will assign 2 times more weightages than criteria 1. Now, this is a point in qualitative context I am mentioning. It will become clear when we consider more of these other different techniques. So, twice more importance, thrice more importance, 10% less importance based on the criteria. So, here it is mentioned criteria 2 is twice as important, while for criteria 3 the level of importance are the same as criteria 1. So, if criteria 1, criteria 3 are same, obviously criteria 2 will be twice with respect to 1, twice with respect to 3. So, based on that the weights are there. I immediately put on the weights, but the qualitative statement would be like this: what is the percentage, what is the importance, what is the level of importance, how many times. So, once the weights are given, I multiplied and find out y. So, the values are given. So, the values are what we have calculated in this cell. So, this set of point I am only reading till 3 places of decimal 0.083, 0.062, 0.100, 0.125, 0.250, 0.050, 0.041, 0.0187, 0.010, 0.100. So, these are y which in this, even though different because the y calculations are different, they are based on this. Now, we will take a pause. If you remember, in the topsis method we considered the PIS and the NIS, the distance from the most positive and most negative. Here the idea was, if you remember, the concordance set and discordance set, liking set, disliking set. Now, here also I mentioned one point in details, that liking set and disliking set does not mean that we are only taking one alternative. So, considering there are two alternatives A1 and A2, for A1 I find out the liking set, disliking set, for A2 also if I find out the liking set, disliking set. So, what does it mean? To repeat, consider I have taken alternative A1. So, obviously, there are some positive points, but obviously, it can be possible that they can be negative points on two accounts, negative points based on the account that there are some disbenefits accruing for alternative A1. Consider buy the car, very good car, but the maintenance cost is very high. So, that is the disbenefit. Or consider the college, college is very good, but cost of studying is very high. So, that is the disbenefit. Similarly, if I take the other alternative, they can be disbenefit also. Benefit, say for example, for buying a very less costly car, that is a benefit, I am paying less, but the disbenefit may be longevity of the life, or later on the maintenance cost exponentially increases, because for wear and tear, or the road conditions are not good, the car has to be maintained much more often. So, we will consider these levels of benefit and disbenefit. So, we need to determine the concordance and the discordant indices sets. Based on the indices set, we will formulate the concordance matrix and the discordance matrix. Now, what is the concept of concordance and discordance? What I mentioned, I will repeat it. Concordance index is defined as the amount of evidence to support the conclusion that alternative AI outranks, dominates, or is better than AJ. Now, that is the index. So, obviously, I have to compare that based on each and every criteria. Similarly, what does the discordant index means is the counterpart of that, and it in very simple mathematical terms one can say that is the discordant index is the complement of the concordance index based on the disbenefit which I am getting by choosing AI over AJ. Now, the distance concept, and here the distance concept I will slightly go into a different analysis of trying to analyze the distance. Now, when we are discussing the liking disliking, consider this example. and I will give you a mathematical background of that also. So, if I consider first the mathematical background, I will draw it here. It has nothing to do with the problem solving, is basically to do with the analysis. So, consider I have axis x and y, and I am trying to find out or estimate in simple statistics. So, if I estimate, I need to find out the variance. If you remember, the variance is square, quadratic in form as per the formula. So, if I put the concept of quadratic equation for trying out to find out the variance function looks quadratic like this. Now, why I drew it? If I plot the value of delta, what is delta? Delta is the difference between the actual value and the estimated value, parameter and its estimate. So, this point which is the origin where both the estimate and the parameter exactly match. So, delta is 0. On to the right, it on as I draw, it is positive, on to the left is a negative. So, if I consider a parameter value of, say for example 4. So, in one case we estimate 4 by a value of plus 2, in another case we estimate 4 by a value of, say for example minus 2. So, in this case consider for, I will give you an example, plus 2 minus 2. Let me take the value of wait. I will take a much better example. Wait, let me consider the value as theta, which I want to find out, and theta hat. I am using a symbol as the estimate. So, difference between theta hat minus theta is delta, which I am measuring. I will come to the values of the parameter and the estimate later on. First, let me come to the concept of delta only. Consider in one case theta hat minus theta is plus 2, and another case the difference between theta hat minus theta is minus 2. So, plus 2 whole square is 4, minus 2 whole square is 4. So, if I basically try to find out the quadratic value. So, in both the cases for negative and positive was of same equal distance onto the right and the left. But the answer is that when I come to the analysis here, is it true? The answer is no. Why not? Let me give you two examples before I proceed. Consider an example where and in concept of a real, consider an analysis, I win or I find out 100 rupees, and in another case I lose 100 rupees. It is a very simple and rudimentary example, but try to understand that. So, my net worth or the value of the satisfaction of winning 100 rupees with respect to the value of minus 100 rupees being a loss, my level of dissatisfaction that I have lost 100 rupees would be much more than winning 100 rupees. So, my loss I am quantifying much at a much higher level, even though 100 rupees losing and gaining worthwhile is the same in units. Consider another example, and here I am trying to basically say, for example, if I consider from a civil engineering perspective, I want to build a dam. The dam's height is basically actually should be 120 feet, but consider there are two instances. In one case the dam's height is 122 and another, it has been built, and another case it has been built to 118. So, what is the difference between 120 and 122? Is in one case if I consider it is plus 2, another case 120 118 is minus 2. If I square them up considering the quadratic of the concept of variance, both case plus 2 whole square is 4, minus 2 whole square is 4. So, is equally penalized. But the question is that in the practical sense, is it right? The answer is no, wrong, it is not right. Why? In the case if I build it to 122 feet, there would be some extra cost, manpower, extra materials, extra time. But why 122 has been decided? Because on an average the flood comes and the level of the water max can reach 120. So, in the case if it is built on 122, then the probability of the water breaching the dam is much less. Now, the answer is much less with respect to what?
Consider if it is built to 118 and the flood comes and the average height of the water is 120, in that case the probability of it breaching the dam is much higher. So, initially when you have built it to 118, the amount of manpower, amount of material, amount of time taken was much less, but the catastrophic loss it will be happen due to the environment impact of the flood overrunning and breaching the dam would be much more. So, in that case here for this example, overestimation of 120 by 122 with respect to 120 and 118, overestimation would not be penalized, underestimation will be penalized. And there can be other examples of overestimation being penalized, underestimation not being penalized, and so on and so forth. So, with this example and with this thing in the mind, we will discuss the problems accordingly. Thank you very much and have a nice day.